The universe is a busy place, filled with wonders we are only just beginning to map. On July 1, 2025, astronomers using the Asteroid Terrestrial Impact Last Alert System, or ATLAS for short, spotted something new. It was a faint point of light, moving with a purpose, that immediately set it apart from the usual cosmic wanderers. This object, quickly designated 3I Atlas, was not just another asteroid or comet born in our own solar neighborhood. It was a traveler from a distant star system, the third such interstellar visitor ever confirmed in human history. The discovery sent ripples of excitement through the global astronomical community, turning the world's most powerful telescopes toward this fleeting guest. Everyone wanted a closer look. This wasn't just a routine observation, it was an event. The object was barreling through our solar system on a path that shouted its alien origins. It was moving too fast, far too fast to be caught by our sun's immense gravity. Its trajectory was a perfect hyperbola, a cosmic arc that would swing it around our star and fling it back out into the void of interstellar space, never to return. Looking back at older images, scientists realized NASA's test satellite had unknowingly captured it even earlier, on May 7, 2025, when it was still far out between the orbits of Saturn and Jupiter. This early glimpse provided a crucial baseline, a starting point for the incredible story that was about to unfold. The news spread like wildfire. Observatories from Chile to Hawaii, and space telescopes like Hubble and James Webb, all cleared their schedules. This was a rare opportunity to study a piece of another solar system up close, a sample delivered right to our cosmic doorstep. What secrets did it hold? What could it tell us about the star systems that lie light years away? The object was a time capsule from an unknown place and an unknown time, and scientists were determined to read its message before it slipped away forever. The race was on to gather as much data as humanly possible, to understand this mysterious messenger from the great beyond. As 3I Atlas drew closer to the sun, its strangeness only grew. It wasn't just its speed or path that was unusual. The object began to behave in ways that defied our understanding of comets. It was brighter than it should have been, active when it should have been quiet, and its chemical makeup was unlike anything we had ever seen before. Each new piece of data added another layer to the puzzle, transforming what began as an exciting discovery into one of the most profound astronomical mysteries of our time. The world watched, captivated, as this celestial enigma prepared for its closest approach to our sun, a moment that promised to reveal even more of its secrets. Our solar system has had interstellar visitors before, but 3I Atlas was immediately different. The first, 1I Oumuamua, was a small, dark, cigar-shaped object that sped through our system in 2017. It was mysterious because it showed no visible coma or gas cloud, yet it accelerated as if something was pushing it. The second, 2I Borisov, discovered in 2019, was much more familiar. It looked and acted like a classic comet, complete with a dusty tail, assuring us that comets from other star systems could be very similar to our own. 3I Atlas, however, seemed to be a blend of both the strange and the familiar, yet it ultimately carved out its own unique category of weirdness. Unlike the small and inert-looking Oumuamua, 3I Atlas was gigantic. Initial estimates placed its solid nucleus at around 11 to 20 kilometers across, but as it got closer, scientists revised that number upwards to a staggering 46 kilometers. That's a mountain-sized object, with an estimated mass of 33 billion tons, hurtling through space. But it was the object's coma, the vast cloud of gas and dust surrounding the nucleus, that truly boggled the mind. This glowing halo extended out to a radius of 300,000 kilometers, making the coma nearly half the diameter of our own sun. It was a colossal presence, far larger and more active than 2I Borisov ever was. The origin of 3I Atlas also adds to its mystique. Based on its trajectory and composition, some astronomers have speculated that it comes from a star system perhaps twice as old as our own. Imagine that. This object could have been formed in a planetary system that was already ancient when our Earth was just beginning to take shape. It carries with it the chemical history of a much older part of our galaxy. This makes it fundamentally different from Borisov, which seemed to come from a system more like ours. 3I Atlas is a relic from a different cosmic era, a true alien in every sense of the word. Its path through our solar system was also a gift to science. It reached its closest point to the Sun, known as perihelion, on October 29, 2025, at a safe distance of about 1.4 astronomical units, or 130 million miles. This was far enough to prevent the Sun from completely tearing it apart, yet close enough for its heat to trigger fascinating activity. After its solar flyby, it will pass back out beyond Jupiter's orbit by the spring of 2026, giving astronomers a precious window of several months to study it. This extended visit is a luxury we didn't have with the fleeting passage of Oumuamua, allowing for an unprecedented observational campaign. One of the first clues that 3I Atlas was no ordinary comet was its incredible brightness. When the TESS satellite first spotted it back in May 2025, it was already glowing intensely. At that distance, beyond the orbit of Jupiter, our solar system is a very cold place. Most comets, from our own Oort cloud, are made primarily of water ice, which needs much more solar radiation to turn into gas, a process called sublimation. They typically turn on and form a bright coma only when they get much closer to the Sun, usually somewhere inside Jupiter's orbit. 3I Atlas, however, was already putting on a spectacular show when it was still deep in the cold outer solar system. This early activity was a major puzzle. What was causing this object to shed so much material so far away from the Sun's warmth? The answer would come later from spectroscopic analysis, but the initial observation was baffling. It suggested that 3I Atlas was not made of the same stuff as our local comets. Something on its surface was turning into gas at extremely low temperatures, creating the enormous, brilliant coma that made it visible from so far away. This was not just a minor difference, it pointed to a fundamentally different chemical makeup and therefore a different birthplace, one with very different conditions for planetary formation. The brightness continued to increase as it journeyed inward. On August 2, 2025, an image from the 2-meter twin telescope in Spain captured a stunning event. A massive jet of material erupting from the object's surface. It looked like a volcanic plume, blasting gas and dust into space with incredible force. Such outbursts are not unheard of in comets, but the scale of this one, combined with the object's distance from the Sun, was extraordinary. It was as if the alien visitor was actively announcing its presence, putting on a light show for the dozens of telescopes now trained upon it. Each new image revealed a dynamic and powerful object, not a simple inert rock. As it rounded the Sun in late October, 3I Atlas had already lost an estimated 2 million tons of its mass to this intense sublimation. While that sounds like a lot, it is a tiny fraction of its total 33 billion ton mass. This suggests the object is robust and has likely survived many such journeys through its own home system, or perhaps even other star systems, before arriving in ours. Its surprising brightness was the first major anomaly, the first sign that scientists were dealing with something truly special. It was the curtain raiser for a series of even stranger discoveries that were yet to come, discoveries that would challenge our very definition of what a comet can be. When astronomers finally got a chance to analyze the light from 3I Atlas's enormous coma, they found the answer to its early brightness, but it only deepened the mystery. Using powerful spectrographs on telescopes like the Very Large Telescope in Chile, they broke down the light to see what chemicals were present in the gas cloud. The results were stunning. The coma was overwhelmingly composed of carbon dioxide, or CO2. In fact, the data showed that for every 1 part of water, there were 8 parts of carbon dioxide. This means it has a staggering 16 times more CO2 relative to water than any typical comet from our solar system. This discovery was a game-changer. Carbon dioxide ice sublimates or turns directly into gas at much colder temperatures than water ice, around -78.5 degrees Celsius or -109.3 degrees Fahrenheit. This perfectly explained why 3I Atlas was so active and bright when it was still far out in the cold depths of the solar system. Its surface wasn't frozen water. It was a vast expanse of frozen carbon dioxide, which began to vaporize as soon as it felt even the faintest warmth from our distant Sun. This composition suggests it formed in an extremely cold region of its home star system, a place far different from where our own comets were born. The implications of this are profound. The chemistry of a star system dictates what kind of planets and comets can form there. A system rich in carbon dioxide would have a very different environment than our own, which is relatively water-rich. This visiting object, 3I Atlas, is a physical sample from such a system. It's like a geologist receiving a rock from another planet. By studying its composition, we can learn about the chemical building blocks available in other parts of the galaxy. This single object provides a window into the diversity of planetary systems out there, suggesting that the recipe for making comets is not universal. The sheer scale of the gas production was also impressive. The massive Comet, stretching hundreds of thousands of kilometers into space, was being fed by the constant sublimation of this CO2 ice. It was like a giant slow-motion explosion that had been going on for months. This unusual composition set Three-Eyed Atlas apart from every comet we had ever studied in detail. It was a true alien, not just in its origin, but in its very substance. This strange chemical signature was a core piece of the puzzle, but it was far from the only anomaly that this visitor presented to a bewildered scientific community. Comets are famous for their beautiful tails, which are almost always pointed away from the sun. This happens for two simple reasons. The solar wind, a stream of charged particles flowing from the sun, pushes the gas, or ion tail, directly away. At the same time, the pressure of sunlight itself pushes the lighter dust particles, creating a second, often curved dust tail that also points generally away from the sun. It's a fundamental law of cometary physics. But during its approach to the sun, in July and August of 2025, Three-Eye Atlas decided to break that law in the most spectacular way possible. For several weeks, astronomers watched in disbelief as the object's primary tail pointed toward the sun. This was completely backward. It defied everything we know about how solar wind and radiation pressure affect comets. An anti-solar tail, as it's sometimes called, is not entirely unheard of, but it's usually a minor optical illusion caused by our viewing angle. This was different. It was a prominent, well-defined feature that was undeniably oriented in the wrong direction. The object was flying toward the sun, and its tail was streaming out in front of it like a cosmic banner leading the charge. Scientists scrambled to find an explanation. Was there some unknown force at play? Could the object be generating its own magnetic field that was interacting with the solar wind in a bizarre way? Or was the material in the tail so heavy that it wasn't being pushed away effectively by sunlight? None of the conventional models could adequately explain this behavior. It was a true anomaly, a direct observation that contradicted decades of established theory. The sunward-pointing tail became one of the most talked-about features of Three-Eye Atlas, fueling both serious scientific debate and wild public speculation. Then, just as mysteriously as it appeared, the anomaly corrected itself. By September 2025, as the object continued its journey, the tail swung around. It reversed its orientation and began pointing away from the sun, behaving exactly as a normal comet should. The strange phase was over. This transition only added to the puzzle. Why did it point toward the sun for a few weeks and then stop? Did its rotation change? Did the composition of the material it was ejecting suddenly alter? Whatever the cause, this temporary defiance of solar physics left a lasting impression. It was another sign that Three-Eye Atlas was an object with a complex and perplexing character. As if a sunward-pointing tail and a carbon dioxide-heavy composition weren't strange enough, Three-Eye Atlas had another, even more baffling secret hidden in its chemical makeup. When astronomers used high-resolution spectroscopy to analyze the specific elements within the coma, they found something that seemed almost impossible. The gas cloud contained clear and unmistakable signatures of nickel metal. Finding metals in a comet's coma is not unusual. As the nucleus heats up, various elements vaporize. But the nickel in Three-Eye Atlas was alone. There was no trace of iron. In the cosmos, nickel and iron are almost always found together. They are forged in the hearts of dying stars through the same nuclear processes and tend to condense into solid materials at similar temperatures. Asteroids, meteorites, and even the rocky planets in our solar system all contain both elements, usually with iron being much more abundant. On Earth, separating nickel from iron is a complex and energy-intensive industrial process. To find nickel in a natural cosmic body without a corresponding amount of iron is, to put it mildly, exceptionally weird. It suggests a formation process that is completely alien to us. The discovery sent shockwaves through the scientific community. How could this be possible? Some scientists tried to find a natural explanation. Perhaps there is some unknown chemical process that allows nickel to sublimate at a much lower temperature than iron, but only under the specific conditions present on Three-Eye Atlas. Or maybe the object formed in a part of its home nebula where, for some reason, all the iron had been depleted or locked away in other minerals. However, no known natural model can easily account for such a perfect separation of these two chemically similar metals. This nickel without iron mystery has become one of the most compelling arguments for those who speculate about more extraordinary origins for the object. The presence of pure, or at least iron-poor nickel, is often a hallmark of advanced manufacturing. It's a material used in specialized alloys and technologies. While no scientist is ready to declare it definitive proof of alien industry, the anomaly is so significant that it forces us to consider possibilities outside of conventional astrophysics. The greenish glow of the object's coma might even be caused by this vaporized nickel, a color that only adds to its otherworldly appearance. The case of the missing iron remains an unsolved and deeply intriguing puzzle. With so many unexplained anomalies piling up, it was inevitable that speculation would run wild. The combination of its massive size, its strange CO2-heavy composition, the baffling sunward-pointing tail, and the near-impossible nickel-without-iron signature has made 3I Atlas a magnet for extraordinary theories. While most scientists maintain that a natural, albeit highly unusual explanation is most likely, the data is strange enough to allow for more imaginative ideas to be considered. These are not just baseless fantasies. They are attempts to find a hypothesis, any hypothesis, that fits the bizarre collection of facts. One of the most popular speculative theories is that 3I Atlas is not a comet at all, but an artificial object, an alien probe or starship. Proponents of this idea, like astronomer Avi Loeb, point to the nickel as potential evidence of manufacturing. Perhaps the object is a massive, derelict ship, venting its spent CO2 atmosphere from long-dead life support systems. The sunward-pointing tail could have been the result of a malfunctioning propulsion or stabilization system that briefly fired in the wrong direction. In this view, 3I Atlas is a piece of extraterrestrial technology, a cosmic ghost ship drifting between the stars. Another, even more exotic theory, suggests that 3I Atlas could be a form of life itself, a giant spacefaring silicon-based organism perhaps, that breathes out carbon dioxide as a waste product. In this scenario, the eruption of jets and the changing tail could be biological processes, reactions to the new environment of our solar system. While this idea sounds like pure science fiction, the universe is under no obligation to conform to our limited understanding of what life can be. When faced with phenomena that defy known physics and chemistry, it is part of the scientific process to explore even the most unconventional possibilities. As of today, October 30th, 2025, 3I Atlas has just passed its closest approach to the Sun. The next few days and weeks are critical. Scientists are watching intently to see if its trajectory changes in any way that cannot be explained by gravity alone. Any slight anomalous acceleration could be a sign of propulsion, what is known as the Oberth effect, lending weight to the artificial origin theory. For now, we know it is a massive object from an old star system, made of CO2 ice, and containing iron-free nickel. Its tail once defied the sun. What it truly is, a bizarre natural comet, an alien artifact or something else entirely, remains the greatest mystery in our solar system today. We must watch and wait and wonder.